I will kick us off. I've got my colleague Douglas also on the call. But my name is Reza, and I'm thrilled to have you guys here today. Maybe just some quick housekeeping while everyone is joining. People usually ask whether the session will be recorded. Yes, it will, and we will share a link with you after the event. At the end of the session, there is a QR code for feedback. I would really greatly appreciate it if you could take a moment to just provide some answers to 4 quick questions. And then I will try my best to leave enough time for questions at the end. Please feel free to add any questions to the Q&A as we go. Douglas will assist at the end with curating the questions for discussioning and maybe answering some of them as we go along. So I am a co-owner and director of Data Lab Solutions, where I've spent the last almost 9 years of my career. Data Lab is a data analytics consultancy where we help clients implement end-to-end modern data platforms so they can create value from their data. A brief history of me. I studied industrial engineering and at a later stage, a degree in strategic management. I started my career as a management consultant where we consulted on enterprise architecture, business process engineering, and organizational design. From there, I felt I needed to get some hands-on experience in industrial engineering, where I joined a production company as a continuous improvement engineer. And this is really where I fell in love with data. I needed data to determine where the biggest cost-saving opportunities or improvement areas were. And I also had to track the metrics to see if the interventions made a difference. After that, I was a business analyst, assisting with translating business processes into ERP system configuration, and then transitioned fully into data as an analytics engineer, delivering on clients' data dreams. I'm a member of an international organization called EO, where we learn how to effectively run and scale businesses as entrepreneurs. And as this was an invite-only session, I'm happy to share my email and encourage you to reach out if you have any further questions or would like to discuss things further. I made an agenda for today so you guys know what is coming and to try and keep myself aligned to time. We will kick off with an overview and some background around Gen AI, provide some context for LLMs and briefly look at the scope of AI techniques. We will then take a deeper dive into large language models, discuss the various types and considerations. We will also look at some practical examples of the use cases in analytics. And then finally, we will land with some practical and next steps on what you can go and do. And then finally, we will head to the Q&A. So let's dive in. Traditional AI, often referred to as machine learning, has primarily focused analytic tasks like classification and prediction. Gen AI now goes a step further with its ability to create new and original content. This creative breakthrough has the potential to transform nearly every industry, enhancing human creativity and pushing the boundaries of what machines can accomplish. I think while many organizations have a very clear understanding of the outcomes they anticipate from general Gen AI applications, there's often uncertainty about the methods to achieve the results. Different outcomes would necessitate different approaches, both in terms of the data sets you curate and the AI models you use. But let's start with something light, unpacking the different types of knowledge. First of all, the known knowns. These are the insights and metrics that are already known and understood by the business. The business knows what it wants to measure, and it's often referred to as corporate BI. Traditional corporate BI tools and dashboards are used to monitor and measure these known metrics, providing a structured and reliable approach to reporting and analysis. Then we get the unknown knowns. These are the insights that are known to the business but not yet identified or measured. The organization might have an idea of what it wants to measure but needs further investigation, typically through self-service. Self-service empowers users to explore data and uncover these insights on their own. This approach allows more flexibility and user-driven investigation, helping to surface insights that might not be immediately obvious. And mostly the topic of today is around the unknown unknowns. These are the insights that businesses is completely unaware of and has no prior knowledge about. These insights often reside in large amounts of unstructured data. The business has no idea what insights are hidden in this data, and typically the approach is data science, machine learning, and AI. These advanced techniques are required to discover these unknown unknowns. These methods can analyze large and complex data sets to identify patterns much easier than humans can. So what is generative AI? Gen AI can learn from existing artifacts to generate new artifacts that reflect the characteristics of training data but don't repeat it. It can produce a variety of novel content such as images, videos, music, speech, text, software code, and product designs. Gen AI uses a number of different techniques that continue to evolve. Foremost are AI foundation models, which are trained on a broad set of unlabeled data that can be used for different tasks, with additional fine-tuning as well. Complex math and enormous computing power are required to create these trained models, but they are, in essence, prediction algorithms. Today, Gen AI most commonly creates content in response to natural language. It doesn't require knowledge or entering of code, but the enterprise use cases are numerous. So the journey to Gen AI is a series of increasingly frequent breakthroughs that make sense of natural language. Around 2010, AI researchers working on natural language translation discovered that models exposed to vast amounts of text produced much better results than models using top-down grammatical rules. In 2014, language models began to make sense of the meaning of words in natural language by analyzing the context in which the word appeared. And advances from 2017 to 22 resulted in language models that can serve as foundations for customization. Creating models that is cost prohibitive, but once created, they can be customized using small amounts of additional data to create state-of-the-art performance on new tasks without significant investments. And 2022 marked the arrival of ChatGPT, which gave the users a way to access large language foundation models. The brilliance of ChatGPT is not just in the incredibly advanced model at its core, but equally it is the ability to tap into this model, conversing with it in natural language. So let's look at how LLMs fit within the broader context of AI. Gen AI refers to AI techniques that learns from a representation of artifacts derived from data and models. These techniques are used to generate new artifacts and they are related to the original ones. It encompasses various forms of AI that create new data based on learned patterns and existing data. Foundational models are large machine learning models trained on vast amounts of unlabeled data using a transformer algorithm. This training results in a versatile model that can be adapted for a very wide range of applications, and they serve as a base model for more specialized AI systems like large language models. Large language models are a type of foundational model AI that is trained on extensive amounts of text data to interpret and generate human-like textual output. LLMs are specifically designed to understand and produce language, making them essential for applications that require natural language processing. Examples include Lambda, BERT, Llama, and Ernie. There are many of them. And then finally, we've got the conversational chatbots. These are applications built on top of LLMs, designed to facilitate natural conversational interactions with users. They leverage the common capabilities of the LLM to provide coherent, contextually relevant responses in a dialogue format. Examples include BART and ChatGPT. It is important to understand the vast landscape of AI techniques. This can get a bit heavy, and I've tried to summarize it as much as possible. Some of the established AI techniques include probabilistic reasoning. This category involves using machine learning techniques to unveil unknown insights through data correlations by identifying patterns and has been around since the 1980s. A common use case is predictive analytics for customer behavior based on past purchase data. Computational logic involves using rule-based systems to structure known knowledge into a coherent and organized manner and has been around since the 1950s. An example of this is regulatory compliance systems that apply consistent business rules to ensure legal adherence. And then we've got optimization techniques, around since the 1970s, and it focuses on finding optimal combinations of resources to maximize benefits while managing trade-offs. A common use case is supply chain optimization to minimize costs while still meeting delivery requirements. In addition to these established techniques, several emerging AI methods are quickly gaining traction. First of all, natural language processing, which provides the intuitive communication between humans and systems, including tasks like recognizing, parsing, interpreting, tagging, translating, and generating natural languages. An example here is the chatbot that understand and respond in natural language. Then there is knowledge representation, which facilitates access and analysis of data through knowledge graphs or semantic networks, which are intuitive for very specific types of problems. And then there is agent-based computing, which involves the autonomous goal-oriented programs that act on behalf of users or other programs. This technique is becoming very popular now with the applications like chatbots. An example here would be autonomous software agents that handle customer service inquiries. Our focus today will mostly be around natural language processing. So, large language models, LLMs, are advanced AI systems designed to understand the intricacies of human language and to generate intelligent and creative responses when queried. AI systems with human-like reasoning capabilities has been around since the 1950s, but it is only with the advent of LLMs that they've gained more widespread adoption. As impressive as they are at language generation, reasoning, translation, Gen AI applications that have been built on public data can't realize their full potential in the enterprise until they are coupled with enterprise data stores. Let's look at what an LLM is. A large language model is a very sophisticated AI system designed to understand and generate human language. The key components and processes involved in creating a large language model includes a massive data sets. LLMs are trained on vast amounts of text data, which provides the foundational knowledge needed to understand and generate language. The model is exposed to diverse and extensive training data, enabling it to learn patterns, meanings, and structures within the language. During training, LLMs use self-supervised learning techniques. where they can learn to predict parts of text, such as the next word in a sentence, based on the context provided by the surrounding text. The model employs deep learning algorithms, which involves complex neural networks with multiple layers that allow it to learn and represent intricate patterns in data. LLMs use transformer architecture. This is a state-of-the-art neural network design that allows for efficient processing of large amounts of data and captures long-range dependencies in text. And then finally, after initial training, LLMs undergo fine-tuning on specific data sets to improve their performance on particular tasks, domains, and enhancing their relevance and accuracy. One thing to remember is that Gen AI models and the decisions made from these models are only as good as the data that supports them. The more data these models ingest and the more situations they encounter, the smarter and more comprehensive they will become. What are LLMs good at? They're good at search. They excel at retrieving relevant information from vast data sets by understanding natural language queries and providing precise results. They can categorize text into predefined labels such as spam detection in emails or topic identification in documents. They can group similar pieces of text together based on context and content, aiding in the discovering of patterns and relationships inside of the data. They can condense lengthy documents into concise summaries and highlight the key points and essential information. They can create coherent and contextually relevant text, such as writing articles, stories, or generating responses in chatbots. They can rewrite, paraphrase text, improving clarity or style or adapting the content to a specific audience. LLMs identify and pull specific pieces of information from text, such as dates, names, or other entities you are looking for. They can evaluate and score text based on various criteria, such as relevance, quality, or compliance with guidelines. And finally, they can assess the emotional tone of text, determining whether it's positive, negative, or neutral. Useful in understanding customer feedback and things like social media posts. Forgive me for the awful slide here, but it's worth spending a minute on. There are many LLMs in the market. This is not a complete list. But when selecting a large language model for your needs, several key considerations should guide your decision. The first of all is the developer and model reputation. The developer's track record and the specific model's reputation can provide insights into things like reliability, support, and community trust. We would suggest opting for models from reputable developers like OpenAI, Google, DeepMind, or Mistral, which are known for robust performance and ongoing support. The second is parameters. The number of parameters in a model is a primary indicator of its complexity and capability. More parameters generally mean the model can understand and generate more nuanced text. Larger models like ChatGPT-3 are powerful, but they require significant computational resources. Smaller models might be sufficient for less complex tasks and more resource efficient. Very important is the use case. Different models are optimized for various applications. Common use cases include things like text generation, summarization, translation, question answering, sentiment analysis, and more. You need to choose a model that is tailored to your specific need. For example, for SQL generation and coding, a model like Snowflake Arctic might be ideal, where for multilingual tasks, a Rika Flash model could be more suitable. The size of the model, being small, medium, or large, often correlates with the computational resources needed for training and inference. We need to balance the model size with your available computational resources and the specific requirements of your application. Large models offer more capability but higher resource costs. And then finally, the token limit indicates how much text the model can process at one point. Higher token limits allow the model to handle longer text inputs. So ensure that the token capacity meets the needs of your application. Rika Flash is ideal for processing very long documents, for example, while smaller models might suffice for shorter pieces of text. So selecting the right large language model for an application is really critical. Using a selection framework can really help to ensure systematic and comprehensive assessment, aligning this with business objectives, technical requirements, and also ethical considerations. So here are some guidelines around the selection framework. Identify the specific use cases and prioritize them based on strategic importance, potential impact, and alignment with business goals. Assess whether the LLM is proprietary or open source. Evaluate performance metrics like accuracy, reliability, and scalability. And also identify potential risks like biases, ethical concerns, regulatory compliance, and security vulnerabilities. Evaluate the organization's data infrastructure and readiness to support LLM deployment. Assess the quality and diversity of training data for compatibility with the LLM's requirements. And then assess the flexibility and customization options for domain-specific datasets. Evaluate the ease of customization, compatibility with existing infrastructure, and deployment options. Conduct then a cost-benefit analysis, considering total cost of ownership, licensing fees, computational resources, and maintenance cost as well. Refine this selection based on your budget, resource availability, deployment timelines, and strategic fit. Compare the performance cost and deployment considerations to identify the most valuable option. Select then the LLM that best balances performance, cost, effectiveness, scalability, and strategic alignment. And then finally, pilot it as a proof of concept in a controlled environment to validate performance and usability, gather feedback, iterate, and refine the deployment based on ongoing evaluation and optimize impact and value. Many of us wonder about the risks involved in using LLMs. Some common concerns include lack of transparency. So how do we explain the decisions it makes? Accuracy. What if the AI makes an inaccurate prediction? What if the AI is biased? What about copyright infringement and IP? And then finally, how do we safeguard our business with cybersecurity and fraud concerns? It is important to understand that some use cases might pose more risk than others. For example, asking AI to generate responses to customers could pose more risk in terms of incorrect messaging or reputational damage than asking AI to do sentiment analysis on large volumes of transcript data, which is something a human cannot very accurately or efficiently do. But it's important that all Gen AI project stakeholders should really take care to protect sensitive data that is accessed and shared with the LLM. When you conduct these projects, typically within a cloud data platform, you can uphold security, data privacy, governance without imposing too much intrusive restrictions on the workforce. The final topic around LLMs specifically is prompt engineering. Prompt engineering is a topic that can be extensively unpacked, and we could probably dedicate a whole hour to this in a future talk. So I want to encourage you to contact us if you're keen to learn more about prompt engineering. For now, this is a very high level overview. So what is prompt engineering? It is a crucial skill in the realm of AI, particularly when working with LLMs. It involves crafting precise and effective prompts or inputs to guide the AI in generating useful and relevant responses. We can compare this to the ability to write elegant SQL queries to guide do the transformations you want it to do. Why does it matter? LLMs are incredibly powerful, but they require clear and well-structured prompts to produce valuable outputs. The quality of the prompt directly impacts the accuracy, relevance, and usefulness of the AI's response. This means a new skill set is required. To effectively control and utilize LLM responses, we need new skills. We need knowledge of LLMs, familiarity with how LLMs work, including their strengths and limitations, as well as awareness of the different use cases. We need to write prompts that are clear, concise, and specific to the task at hand, providing enough context to guide the AI towards generating the relevant and accurate response. And we need to get comfortable with experimenting with different phrasings and structures to find the most effective prompts. So some final guidelines on creating good prompts: be specific and direct, provide enough context, frame your prompts with the necessary background information, define the output format, specify the desired format of the response, provide examples to guide the AI, and iterate and refine. Continuously test and refine prompts based on the responses you've received. So we'll get a bit more lightweight now and practical with an example. I hope you guys are all still with me. I want to talk about three very different use cases for LLMs in a business. The first of all is around the concept of day-to-day efficiency with co-pilots. These are AI-powered assistants for employees and helps them with task automation, knowledge retrieval, document drafting. Think about the SQL Copilot example that can write your SQL for you based on a natural language instruction. Then there is using AI-powered analytical tools where we augment analytics with tools like ThoughtSpot or Power BI using their inherent Q&A type of functionality, asking our BI tool to analyze the data for correlations, for example. And then finally, integrating LLMs into data platforms. An example here would be to enable text analytics for call center transcripts in order to derive sentiment, extract topics, and understand trends. This will be the focus of our example today. So during every business process, data is likely to end up scattered around many different operational systems, from CRM platforms, email correspondences, social media interactions, support tickets. Much of this data in the form of unstructured text, voice, transcripts, video call recordings. Let's unpack this call center scenario. So most larger B2C organizations servicing clients directly will have a call center. Typically, these calls are recorded for quality purposes, but what actually happens to those recordings? Most of the time, they are placed in cheap storage and forgotten about. Hidden away in these call recordings are insights into your customers, your agent performance, potential problems in your SOPs or business processes. Large B2C businesses will have tens of thousands of these calls happening every month, with large teams of call center agents spending hours talking to clients and spending time on processes post-call as well to capture next steps, to create summary, or simply to categorize calls. Not to mention the systems and technologies facilitating the process. There is a real cost to this. Data quality is also typically a really big problem. When the pressure is on to service the next client, manual post-call work falls off the wagon and inaccurate or incomplete data is then captured. And then finally, in an attempt to understand the customer better, businesses typically send out surveys to clients after a service interaction, adding yet more cost to the process. And with a typically low response rate, they still cannot accurately understand their customer. So in the context of that problem statement, we'll have a look at some common use cases for LLMs. The first one, as mentioned before, information extraction. So this is extracting named attributes from the unstructured data. We can ask it, for example, what product was discussed. Summarization, clear and concise summaries of long unstructured text. Text labeling and classification. So we can go and assign predefined categories to open-ended text. An example could be to ask the model to categorize the topic of the call into one of these options. Scoring. So we can attribute a score based on business rules. An example here could be anger, so detecting the level of anger in a call. And then finally, sentiment analysis, deriving the overall sentiment of the call. Was it positive, negative, or neutral? This is an example of a conversation between an agent and a customer. This call center handles complaints for banks, and I really don't expect you to read and understand what is happening in the conversation. So I'm going to highlight a few things in this long piece of text. First of all, the customer seems to be extremely upset about some fraudulent charges. They feel that it has been a nightmare and it has caused inconvenience and stress to the customer. They are threatening to take legal action, and the agent has some tasks to do. He needs to follow up and he needs to keep the client updated. So this is supposed to be a non-technical session, so I've converted the architecture diagram into some simple steps to explain the process. I will also not elaborate on the specific technologies used or the technical implementation in this talk, but absolutely feel free to reach out anytime if you want to know more about the full delivery of this type of data flow. So first of all, transcript data was stored in a JSON format in a data lake like S3 or blob storage. This data was then ingested through an extract process into a structured table containing two things, the call ID and the long piece of text. We then configured the global context for the LLM, explaining to the model that it is analyzing a complaints call for a bank between a call center agent and a client, and also the various outputs we require. We'll go through them briefly in the next slide. We then let the AI component do the work to analyze each transcript step by step and produce the attributes we specified in the output prompts. These generated attributes were then stored in a structured star schema, which is a way to model data that is ideal for analytics. And then finally, we connected this data into a visualization tool so that we can go and explore the results. Configuring the outputs. This was some of the outputs that we've specified. So we asked what the complaint reason was. We asked what the language was that they were speaking in the call. We asked to do sentiment analysis, and a couple of additional things. These outputs can be seen as additional columns or attribute that is added now to our table of data. And you can see that for each output, there is a context that is supplied in natural language. For this specific one, we asked it to categorize the call into one of the following options: fraud, product complaint, and so on. It is important to remember that the global context that this is a call between an agent and a client still remains. So you can have these different contexts without repeating the global context. So let's have a look at the outputs produced by the LLM. Again, important to remember that the only data provided was the text of the transcript between this agent and the customer. The rest of the data was produced by the LLM. So first of all, NPS and NES are metrics that's used to measure customer satisfaction and emotional engagement. And this is an example of using an LLM to score data. The model was prompted to derive these scores based on the transcript and instructed to give it a range between 1 and 10. Sentiment, the LLM here was prompted to do sentiment analysis on the call by specifying whether the call was positive, negative, or neutral. And naturally, the calls seem to be mostly negative, as this is a complaint center for a bank. Then complaint, where am I now, is resolved. So this is an example of extracting information. The model was requested to determine whether there were any further actions required by the agent. Complaint categories is an example of text labeling and classification, where the model was given a list of categories and asked to categorize the calls into one of those listed categories. Another example of information extraction is the complaint reason. The model here was asked to provide one word to describe the topic of the call. And you can see here that the inside of the top 5, there's only 16 calls. So it did have quite a wide range of topics that it came up with. Products is also an example of information extraction where the model was asked to provide the name of the product that was discussed. And then finally on this page, call summary is an example of summarization where the model was asked to summarize the call within a specified amount of words. Delving further into some more examples here, the call summary was then also translated by the language model into Afrikaans and Xhosa. I cannot verify the Xhosa, but the Afrikaans seems to be quite well. And then finally, we asked the model to generate an appropriate email response in a specified amount of words and tone to be used as a base for the agent to review and send on to the client. So this is specifically the angry customer example we looked at earlier. And what I want to highlight here is just the attributes that were created. So the complaint reason, which was something that the model had to come up with, one word to describe the call, was fraudulent. The complaint category was the list provided to it, and it seems to have drawn the same conclusion there. NPS and NES scores are really low, which we can understand having read partially that transcript, and the sentiment of the call was negative. So what is the business value and opportunities inside of an example like this? I think first of all is improved customer experience through personalization, faster resolution time, and understanding the sentiment of our clients. We can enhance operational efficiency through automated summarization, prioritization, and identifying trends of things happening now. We can increase revenue and customer retention through identifying potential upselling or cross-selling opportunities, and also make sure we retain the customers we have. We can make better decisions through using data-driven insights and analyzing performance metrics. We can enhance compliance and better manage risk. And we can create a competitive advantage by uncovering market insights and driving innovations in products and services. So that concludes our example. I just want to highlight two very similar practical other use cases. First is customer feedback and reviews. So data you would need for that could be Google reviews or SurveyMonkey data or any kind of review data you have. And the insights here could be identifying common themes, product strengths and weaknesses, customer satisfaction levels, and areas for improvement. Another example is social media data. So we could look at things like Twitter data, Facebook and Instagram, gauging public sentiment about your brand or a campaign, tracking certain trending topics that might be important for you, identifying influencers, and monitoring a brand's reputation. So that was quite a mouthful. We might be asking ourselves now, what do we do next? We know there is a lot of value to be uncovered from data stored in unstructured formats. And we also know we need to adopt a new way of thinking and acquire a new skill set or two. So data is your core differentiator in the age of Gen AI. The best way to harness and protect enterprise data for Gen AI initiatives is to consolidate this disparate sources of data into some kind of cloud data platform that provides strong security and governance for data and the models customized with that data. How do we get started? Back to business. By specifically analyzing the business in the context of things like strengths, weaknesses, opportunities, and threats, you can gain a comprehensive understanding of the business landscape. This holistic view aids in strategic planning, decision-making, and resource allocation so that you can enhance resilience, capitalize on growth, and achieve long-term objectives. And it really sets the tone for focus. We could also understand the 3 to 7 key objectives for a business first. These are typically the lagging KPIs like revenue growth, but they are the important things. We need to understand what role data analytics plays in supporting those goals, and then identify the impactful use cases that would support achievement of those business goals. And these would typically be your leading KPIs. We also need to understand data maturity, common dimensions that we assess within data. Maturity includes the quality of your data, the completeness of your data, the governance processes, the current management processes, the analytics you're trying to achieve, the data literacy of the team, technology and infrastructure that you have, and also the culture within the business. So we need to understand where we are and agree on the future state of our data maturity. We also need to understand how ready the business is for digital transformation initiatives. Crucial to digital transformation success it includes having an integrated strategy with clear transformation goals. It requires leadership commitment, not just from the CEO, but all the way through to middle management. It means we need to deploy high caliber talent It also means we need to have an agile mindset around governance that can drive broader adoption. It requires effective monitoring of progress towards certain defined outcomes. And it also requires a business-led modular technology data platform. And then finally, we need to discover our high-level requirements. We need to understand what data we have and where it is, what business processes we have and where do they happen. We need to understand who uses the data inside of those processes, and we need to understand how this data is being used. Further to that, the ideal delivery mechanisms for the data needs to be identified. And then we might ask the question, what to do with all this information that we've gathered? You create your business case for the proof of value that you want to deliver. This typically needs to contain a very clear problem statement articulating articulating the challenges and the impact of those data challenges, the proposed solution. So what is the future state vision and business capabilities that we're trying to make with this proof of value? What is the data architecture and technical capabilities that we're producing? We need to look at the benefits and the value proposition. So quantitative and qualitative benefits of what we're delivering and how it actually aligns to business goals. We need to do cost benefit analysis, describing the investment required, and a good analysis of the costs and the return on this investment. And then we also need to understand how we're going to manage identified risks. And finally, we need a plan. What are the phases? What's the governance? And how are we monitoring this? And if you need help with any of this, you obviously have our contact details. And then, some final thoughts just before we close. Large language models are powerful tools, but their effectiveness hinges on how they're integrated into your overall solution. So some key considerations to take home with you. Start with your business need. Before diving into LLM options, clearly define the specific tasks you want the model to accomplish. The biggest and most advanced model isn't always the best fit. Clearly articulate that use case. This will focus and guide your LLM selection process. We need to think beyond the model. Remember, the LLM is just one piece of the puzzle. Consider the overall solution requirements, including factors like data sources and search capabilities. Finding the right data source and ensuring efficient search functions are really crucial for your LLM to perform effectively. We need to embrace the imperfect here. There isn't a single perfect LLM for every situation. Your use case and solution needs will help you choose the LLM that best complements your overall architecture. Prompt engineering. Effective prompt engineering is essential to harnessing the full potential of a large language model. Crafting precise and well-structured prompts can significantly enhance the accuracy and relevance of the AI's responses. And then not all LLMs are equal. Different LLMs have varying capabilities, training data, and optimized for different tasks. Evaluate multiple models and select the one that aligns best with your specific use case. Governance. Implementing governance practices is crucial when deploying LLMs in your organization. Establish clear guidelines for how the models are used, including ethical considerations, data privacy, and compliance with regulations. And then finally, risks and safeguardings. While these LLMs offer powerful capabilities, they also come with risks that must be managed. Implement robust safeguarding measures such as regular audits, bias detection, and mitigation strategies for handling the sensitive data. And I will leave you with that. Before we delve into questions and you run off, I would love your feedback on today's talk. They say feedback is a gift, and I would very much appreciate your feedback. It should take less than a minute to scan the code and complete 4 questions.